So that question comes to us today from Astro Joe 5. What was your favorite experiment on the ISS?
My favorite experiment on the ISS was one that was called SHEAR, and I'm sorry I don't remember what the acronym actually stood for. It was a fluid physics experiment that took place in the glove box, the microgravity science glove box. And I enjoyed that one because it was kind of a hands-on activity where we got to set the equipment up. It was required a careful setup and calibration, and then we got to actually open up or get in and open up this fluid sample, which was a small little dollop inside there, about the uh, size of a peanut chocolate-coated candy, and then it was like a lathe where it rotated, and it's a fluid with polymer strands inside of it, which were microscopic. You couldn't see those, but that affected the physics of the fluid, and so they spun half of it. So you were basically putting a twirl on that dollop of material and then stretching it, and they could actually measure the tension in the fluid that came from the microscopic strands of polymer or plastics that were tangling together. And the reason it was interesting was, first of all, we got to really observe the science taking place, even though we weren't measuring. It was automatically measuring the properties of the fluid. It also has a direct application for the petrochemical and plastic industries. As part of their processing, this is something that they're trying to understand, is exactly how this affects these polymer fluids in the industrial processes. And so it is a direct application, and it was science that they wanted for the industrial use. So it was fun to do something like that.
That sounds like a fun experiment. Thanks for sharing. Great. So again, we've been talking about some of these science experiments. It all sounds great. I have another question coming from the public on Twitter, and it's a science question. We're going to go with this one. Their question, or first of all, it's a greeting from Poland. Hi. I want to ask about hydrotropy. How much have you learned about growing plants in space since June of 2011? This person's been following you. Greets from Poland.
I guess so. Well, we have several different plant growth experiments, and they're quite interesting. One of them, we're growing plants in a centrifuge, and so we're comparing them side by side on board with a 0G, and then the centrifuge spinning so that the plant seeds for the germination and all are growing at 1G. And you can see the difference in just the structure of the plant itself as a very young plant. And you can see in 0G they're weaker, and that appears to be because gravity actually helps toughen things up, because the plant has to work against the gravity itself. It needs more structure, and so it grows thicker stems. The roots will grow down quicker. At least this is just a quick look. I'm not the investigator here, but when you get a chance to look at these samples when you're coming out of the growth chamber, there's another one that has a plant growth medium, and then they grow them. They're looking at and of course it's a little confusing to try to talk about it because I'm not a biologist in this sense, but they're looking at the details of what makes roots grow the way they grow. And this is kind of a fundamental experiment on the surface, but what we're really doing is getting down to the real enzymes and proteins and the way the plant sends the signal to the root system to tell it what to do. And one of the things they're looking at is trying to figure out the amount of impact that light has on telling the plant which way to grow. And so we plant these seeds in a growth medium, and then some of them are grown in a dark chamber, and some are grown in a chamber that has a light over the top of it. And of course that affects the way the upper part of the plant grows, but it also affects the way that the roots grow. And so, it looks like there's maybe a signal that goes to the roots that says, okay, light is that way, therefore down and more nutrients must be the other direction. And so it sends a biochemical signal
In a place where there is no down.
In a place where there is no down, the plant says, okay, gravity's not helping us, but light tells us which way down must be, and so we'll grow in that direction.
Great, that is fascinating. That question comes to us from You're the Cast. The question is, what time zone do you keep in space?
Okay, well, that is a good question. And because you go around the Earth in 90 minutes, you have a sunrise and a sunset every hour and a half. We had to pick a time, and we ended up just choosing GMT or Universal Time to use as the standard clock, and then you can still kind of arbitrarily set what time you choose to wake up, and we set 6 a.m., which is kind of a normal wake up time here on the ground. Of course, it's the middle of the night in Houston. To begin that, and that was just so we can all have a time that we all agree on, that we all can communicate in this standard GMT time. And on orbit, that's what you're always thinking in is GMT time. At the same time, part of your brain is trying to keep track of what time it is back home, because you might want to call home to the family, or call some friends or something like that. So you want to remember what time it is back home, so you don't
waking
call
them up in the middle of the night.
Morning.
Although
right.
I'm sure they would welcome that phone call.
Oh yeah, the first time, not the second time.
I see. So that leads me to another Twitter question we have here. This one comes from Rhythm Reactor. Are there any day and night shifts? Do you rotate duties? Is there a weekend off? I wonder about that.
You bet. Normally, we're all working the same shift. We don't need to have a night watch on the station. We do have a night watch, but that's mission control. They are watching the systems and taking care of everything while we sleep.
So these folks here that we're seeing in this view.
That's exactly right. They are there 24 hours a day, 7 days a week. They are always on duty in mission control, Houston, mission control, Moscow, Huntsville, Tsukuba in Japan, Huntsville, Alabama. So they're in mission control centers around the world, and they're keeping an eye on the vehicle, so we don't have to. So we work a single shift. Everybody gets up at 6 in the morning, and the official bedtime is 9:30 in the evening. I would say we're very rare that we're actually in bed at 9:30 in the evening. That's time to kind of finish catching up and have a little bit of free time. But usually we're trying to get to bed by 10:30.
Okay, great. Thank you.